Hello, everyone. Welcome back to another session. Today I'm going to be demonstrating how to find the smallest index, and index really meaning both the position, meaning the index number 0, 1, 2, 3, etc., and also the element value, meaning the number that's being housed at each of those elements. So if I'm running through 8 numbers, even though I'm comparing 0 to 1 and then 0 to 2, or the smallest of 0 or 1 against the next number 2, then the smaller of 0 and 1 and 2 against the next number 3. What I'm really comparing to are those values. It's the first number 15, the next one 22, etc. So that's what we're going to be doing. And then I'm going to show you how with one tiny change, you can make this same program work for the largest index. And most of you should understand the concept. It's a simple relational operator change, right? All right, so let's hop to it. A lot to do. So I'm going to go ahead and share my screen and share. So one more time, I'm going to go into MindTap to show you what we're going to be doing. All right, so in MindTap, hide this. Well, let me actually, again, as always, make sure I am, in fact, recording. Whoops. Let's see. Okay. All right, so here I am recording. Yes. And I'm sharing. Yes. So that's all good. I've got my volume on, my mic on high. I'm not sharing my picture of me, but I'm sharing my screen. So all good. All right. So, oh, actually, I've already got MindTap open. So I'll go over to MindTap just real quick to show us again 8.2 and 8.3. So 8.2. I start the assignment just to, again, show you. So write a C++ function smallest index. So I may have mentioned in my chapter 8 or unit 8 overview that you don't technically need to have a function to use arrays, but they're wanting us to use functions. So that's the reason, it adds a little bit more code to it. But again, in general, I've mentioned to you several times that functions make our lives easier. It basically lets us have little code snippets and just copy them and paste them and put them in other areas, especially when we're sharing from our own server at a company where we control what we're doing, as opposed to having to put things on jump drives or put things on OneDrive or Drive or Dropbox or whatever online storage we use. But anyway, this is the one that I reviewed as part of the Unit 8 overview, where I said, basically, we're going to be taking 15 numbers, okay? And you're going to put in these 15 numbers they wanted you to do as like a test. So you would have the user, of course, CIN input on this, and then say to them, enter 15 integers. You enter 1, enter 2, 3, 4, etc., 5, 6, 7, 8, 9, then 0, then 10, 11, 12, 13, 14. After you enter this 14th one, which is really the 15th because there's 0 here, then these results come out. First, it's just listing the numbers that you entered as the quote-unquote user, but putting them on one line from left to right, separated by a space in each case, right? Just separating everything by a space. Then it says the position of the first occurrence of the smallest element in the list is, and in this case, 9 would be the answer. Okay, meaning if you look at 0 for the first number, then 1, 2, 3, 4, 5, 6, 7, 8. Position 9 is value 0. Okay, so the position of the first occurrence is of the smallest element is 9, and the value of that smallest element is 0, okay, based on what we just saw over here. So that's all we're going to do. But then I want to show you then 8.3. Again, the same thing, but 8.3, and I'll pretend I'm going to start it as well. But my program today that I've already coded and it's up in REPL is going to show you how to do both of these that easily. All right. So then this is the same thing, but see, now it's last largest index, whatever. And I mentioned to you in my overview for Unit 8 that it looked like they were having us do the last value, the last element in the list, but it ended up, if you look down here, it says the position of the first occurrence, the largest element in the list. But then, so it was exactly the same as 8-2, but in this case, looking for the largest element, not the smallest. Okay, but it's the same code, so you can literally just copy it and paste it in here too, and you'll get an 87 on this one, 100 on the other one, as long as you code it right. And then once you fix, what you got to say from smallest to largest element, and changing it from the function from smallest index to largest index, or whatever they tell you to. But even if you don't make any changes, you'll get an 87. All right, so that's what, and I'm going to put these in here after I demonstrate them at REPL. All right, okay, we'll demonstrate one, and then I'm going to show you how easy it is to fix it over here. All right, so now REPL. So here's my program. So below is an example program to help you with programming exercises 8.2 and 8.3. John Maloney here. All right, so we got our pound include, we got our namespace. In this case, we're using a constant int called array size and assigning the value 8. Remember, if it's a constant, you must assign a value. So basically, we're just this way, not letting the users have any other numbers that they want to enter. It's always going to be, in this case, 8. Obviously, I want to make it different than them. Theirs is 15, right? But they're also using the same thing. So as I've said, from unit 6 and then unit 7 and unit 5 as well, and really units 4, 3, and 2 going backwards, same thing. My code here is pretty well everything that you need without you making many changes whatsoever. But anyway, array size equals 8, right? So then we're doing two functions, because they said we had to have a function, and then I think they mentioned then also print it, meaning print to the screen, so as another function. So a void means we're not returning a value to the calling procedure, and the print array here, all we're doing is having the two arguments that we normally would have, and because we're using a constant, if you preface the data type here int with the term for constant, which is the const, it'll work. Otherwise, it won't work with a constant and that array size. You need to do it because this is an empty string in here. This int x, left bracket, right bracket, remember it's uninitialized. So for us to use this array size of 8 in it and keep it that way, we have to preface it with constant. So you do exactly this on yours and you'll be fine. All right, so constant int x, this is the array, and int size, that's going to basically be this number 8. And then the little index is what I'm calling this one. Again, smallest index or whatever they told us to do it in 8-2 is what you're going to call yours. You can use these same variables unless they specifically tell you variables, meaning the arguments within, that we're using for the function. So again, constant, same thing, because print array is just going to print to the screen, but from the function definition. Little index is going to be called from int main because it's not a void. So it's called, the calling procedure is calling it, and it'll be returning the value of the littlest number to int main, okay, and to the calling procedure in int main, all right? Okay, so then we have our int list. This is just declaring a variable for our one-dimensional array that we're going to be using in the program. Enter 8 numbers. And then we're assigning I. It doesn't matter what we're doing, but I specifically actually did I because 8-2 did, and 8-3 did, meaning using like I's and X's and stuff. I don't really like to use integers this way, but it's okay, and I'm sure you understand what it's doing. But anyway, we're just assigning the value 0 at this point to this integer I so that we can use it as part of our loop. All right. So here I've got a while loop. I also can do this with a for loop. But anyway, so here I equals 0, and here's our loop while I is less than 8, okay? Because it's going to be 0, 1, 2, 3, 4, 5, 6, 7, which means there are 8 characters, right? So we are starting at 0, which means it'll end at 7. And then CIN, meaning the user input, list, the array, I, the array size. So 8. So it's going to go 0, 1, 2, 3, 4, 5, 6, and 7 as we're inputting those 8 numbers. And of course, incrementing up, it's got the opening curly, the closing curly, and that's all it's doing. So the user, meaning me in this case, typing in 8 numbers, each number is being added. So then that's that, okay? Then we're saying list elements. So the list elements are, meaning, the numbers that we're entering, right? And then we're calling print array list array size. Remember, when it's print array is the void. So we're not returning this anywhere. We're just calling it. And in the function definition, we're going to be putting the answers via a simple COOT statement, right? So let's look where we go with this. Why isn't it not selecting? Okay, so that right there. Okay, I'm going to come down now to underneath int main, right? Here's where underneath int main is. And this is the print array. So here's our print array. Remember, the argument names don't matter, but we have to have the two arguments. It again has to be a constant for the list we're using, so we can't change it. And in this case, it's taking the list size now from the list size after we put it into list via the array size. Okay, but what are we doing with it? We're saying int index, again, using for the loop to print the array to the screen. For index equals 0 to less than list size is 8, and then adding 1 each time. COOT is what we're doing. Simple COOT statement. We're not returning it, so we're displaying it right here, the COOT statement. Just because we're now 20 lines lower, the list elements, though, is still here, so it's going to say list elements, because that's a COOT statement. Right? All these other COOT statements, these are after in the program. But list elements will then show those numbers, but we're not returning them anywhere because the COOT is down here, right? And list with index. So list, the array, it was an empty array initially, meaning it was that left bracket, right bracket. Now it's list with index because we're just declaring it as a number. It doesn't matter as long as it's, you know, the right data type. And remember, it was a constant int for list, empty array, meaning right here, empty. So anyway, it's going to be going through the list and just printing each number one at a time. Okay, then we've got little index. So little index, though, is returning a value. It's also being called, but not also being called. This one is being called. So here we are in int main, where after we get the print array, which is done down in the definition for print array, then we're saying the smallest element in the list is, and then we're again taking an array, list little index. So now I'm looking for list little index, and list little index is down right here. Okay, so little index is again underneath the main, right? And the little index is where we're putting our code to actually find the, in this case, the smallest number. Okay, and there's very, very little code in it. I put lots of comments, especially right here, because it's very important for you to understand exactly what's happening. But it's literally nothing. And these definitions, by the way, I was going to say if you remind me, but I'm taping this. You know what? Before I even do it, I'm going to let's see. I can stay here. I'm going to go over MindTap. Here we go, MindTap. And in MindTap, open up my book on the right side. Remember, make it the book big. Okay. And I think I said it was somewhere in the neighborhood of pages 520. Whatever, I think 528 was one and 523 the other. Let's see which one is which. Okay, so 8-3 in this case is demonstrating certain things that you can do with loops and arrays. They're even telling you exactly what to do for each one. So like here, we're just declaring an array. So double, sales 10, double, largest sale, sum, and average. So basically, you can use these variables as part of some of the things that are being demonstrated where they say A, B, C, D, whatever, okay? But all I want to show you, because you need to read these things, right? You need to read them, but every one is a for loop, okay? But look, see, here's largest element in the array. Remember, we're doing smallest and then we're doing largest. Look, this is it. That's your exact code. Other than, obviously, if they tell you, you have to do certain things in terms of what you're doing. But when you're looking for the largest index, if you're using a for loop, or if it's the smallest, it doesn't matter. You're going to start with something. So in this case, max index equals 0 means they're going to be assigning the first value in the array, the 0 position, to max index, meaning the first number is automatically going to be called the highest. So let's say it's 100. Okay, so the first number entered, 100, is assigned to the 0 position in the array. Then look at the for loop. Int index equals 1. Every time you've seen this, it's 0. okay? And then index less than 10. The reason this one is 1, because 1 is the second number. But so now we're using index, not max index, but index. And index in this case is going to end up going into the sales, which is the array that they declared up, 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 up right here, sales index. Okay, so well, that's not the initial, that's initializing it, but anyway, here's the sales array. So sales with 10. So they're not starting it at 0 because we're assigning the first element to max index. So then we're starting here at the second, which means value 1. Remember, it's 0, then it's 1. So if the first one is 100, let's say the second one is 101. Okay, so now it's saying if sales max index, that's 101. You don't look at the position. The position is not the answer right now. We're looking for the biggest number. But 0 represents a value that was entered. And in that case, I said it was 100. And now I'm saying that we'll say that position 2, which is 1, because the other one is 0. So 0, 1. 1 we'll say is 101. So on the if statement, it's if sales of 0, but 0 has a value. That's what you need to understand. Remember, all these are indices or indexes, but you need to know that they represent a number. So 100 is the first sales figure, all right? So is 100, it's an if, so is 100 less than 101, because we're saying this is the second number that we're inputting. So in this case, we would say, yes, it is. So it's less than, okay? So because of that, it's true. So it goes to the next line, max index equals index. Well, index wasn't, this is max index. The index one is the one from the array itself, the second value. So 101 is then sent from index to max index. So now max index is 101, not 100. Pretend the next one is number 2, and that index value is 90. So we had 100, we had 101, and now a 90. So is max index, which is now 101, remember, because we took the index of the last one, it was larger, so we assigned it to it. So is 101 less than 90? No, it's not. So it doesn't go here. It goes back to the top, goes to the next value, okay? This is exactly what I'm doing in my rendition of what you have to do for programming exercise 8.2 and 8.3, all right? But just to show you that that's this one, they give you a little talk about it. This one up here, finding the sum and the average. One of them may be requiring you to do the sum and or the average. Again, they show you, so they're always going to start with something equaling 0, okay? And in this case, it's the more standard where index equals 0, see, same as the sum. But it's because we're not doing anything with the sum at that point. Here, we're taking all the numbers, so we need this to be 0. So sum equals sum plus sales and then up index. But point being, and then after you do all that, remember that one of the benefits I told you about arrays is that when you're doing arrays, you don't need all the code that you needed even in the loops. This is an entire loop. If this was 100 items, that would be it. Sum equals sum plus sales of 0. Sum equals sum plus sales of 1. Sum equals sum plus sales of 2. And of course, 0 represents a number, not 0. It might be 18,202. The next one may be 12,348. You know, whatever. But you're adding all of them up and throwing them into the new sum so that the sum ends up being the grand total of potentially 100 or 1,000 items. Then the average equals sum, in this case hard coding it though, which is not good. But anyway, our average equals sum divided by 10. Okay, literally 3 lines of code. If you put in 10,000 numbers, you'd get the sum and the average of those 10,000 numbers. Okay, so here's the largest element. And here they're showing you how you go through to do the comparisons. That I'm going to be doing this, but without putting it up this way. So you remember page more or less 528 and then maybe 529 because it goes down a page or two with what I was just clicking on or scrolling through. But this is what I'm doing when I'm talking about comparing the first value against the next value against the larger or the smaller, etc. Okay, so very good stuff in here. Okay, and then they're showing you that one now in a programming example. So all of these, though, give you that stuff. Okay, good stuff. This is on about page 528 and 529 look for it. Excellent. All right. All right. But again, I don't want to have another hour and 40 something minutes. I just wanted to show you that on purpose. Let's go back over to my dizzy thing here. All right. So now, remember, now I'm looking for my min index in this case. All right. So going back up here to the main. All right. So I explained what we're doing with the print array. I said the print array is a void. So once it sees it here in line 21, it just goes down to it. Okay. Underneath the main, and here's print array, and it's not doing anything other than it's a little loop. But in this case, the loop is just putting all the numbers. Here's the loop. This is all it's doing. Okay. So as it's going, starting with 0 up until the last item. So 0, 1, 2, 3, 4, 5, 6, and 7 in my case, in the program I'm doing today. All right. And then it's putting a COOT statement with the list and the index, meaning the 0, the 1, the 2, the 3, the 4, the 5, the 6, and the 7. Each one, though, is separated by a space because it's doing it 1, and then it's going back to the 4 again. It's still true. It's coming back, doing another, and then another space. So it's not doing this at the end. It's doing these sequentially, like it's doing the entire part one at a time. So the first number is put in, second number is put in and displayed on the screen. Third number is put in and displayed next to the second number, one space apart on the screen. The fourth number is put in and put on the right side of the screen, one more space in from the third number, et cetera, et cetera, et cetera. Okay. And then the little index is the hard, well, not the hard one, but it's the one we have to be looking for. And I just showed you in the book, in MindTap right here, that book that I just had up. Okay. Where? This is, again, the largest element. They may or may not have a minimum or littlest element, in here as well. But either way, I told you it's the same. There's literally one little tiny thing that would be changed in this to look for the littlest one. And it's a relational operator. So my gosh, it's not that difficult. Back over here. Okay, so now I'm going to go through this part because this is the important part. All right. So I'm now in little index. Okay, and again, remember, little index, it was a function, so I'm calling the function, and now we're using a constant. The constant is going to be the same thing for our list because that was we had in it nothing. We declared it as an uninitialized array, okay? And we're going to take this list size as the array number. That's all we're doing. 2 arguments, but you don't really need 2 arguments for this kind of code, but it's okay, and this way makes it a little easier because you're just seeing it as 2 things. So the array, which is called list, there's nothing between the brackets because it's not assigned yet, but we're going to be assigning list size to it. Okay. All right. So min index equals 0 will end up being the first item, though, in the array, even though it's not mentioning and there's no left and right bracket here, but that's what it's going to be used for. All right. So then 4, and remember, this one is being returned to int main. So we will be returning it with the return statement. All right. But again, we're only returning the value, the high value, the low value, whatever. Okay. So for counter equals 1, because I told you in this case, we're starting on the second because we're going to be comparing the first, which is 0, to the second value, which is 1, even though the 0 is before the for loop, but that's okay. And I'll show you how it's going to work. All right. Now, this is just my big comments. So next line is asking if the min index value is less than the counter 1 value. In other words, is the first number less than the second number? If it is, the counter value will be the new min index. In other words, the value on the right was smaller than the value on the left. So we're going to assign, because assignment goes from right to left, the value on the right will then be the new min index number, replacing the first min index number. Okay. And we then go through, go to the next counter value, and we're asking the same question again. Is the current min index value, we'll say, less than, in this case, it's not counter 1 value, it's counter 2, and then it's counter 3 and counter 4, right? All of those values. But that's what it's just doing. Each time it's checking, and it's always going to be putting the least value in this as min index. If it already is the least value, then the if statement will be false. So it doesn't do anything. But if it's true that that min index is less than the counter or greater than the counter, whatever I just said, then yes, we go back and do it again. All right. So we're going to go to the next counter value and ask the question again and cycle through all items in the loop. what you have to remember is that we're not comparing the index positions. This is, I think, perhaps the hardest thing to get, because every time I'm talking about these numbers, I'm talking about the index. 0 is an index, 1 is an index, 2 is an index. They're all index values, but they have an underlying element or value for the index value. In other words, list, left bracket, 0, right bracket represents a real number. 0 is just the variable. So the variable is technically list, left bracket, 0, right bracket. Then there's list, left bracket, 1, right bracket. List, left bracket, 2, left bracket number 2, right bracket. And we're comparing list, left bracket, 0, close with the right bracket against, oh God, I'm getting confused, sorry, list, left bracket, 1. So we're just comparing numbers, but remember the indexes. So when I talk about index, or I talk about position, that's not the value. That's not the actual number, but it's a number to represent a variable, and that's what we're actually looking for, okay? So what you need to remember is that we're not comparing the index positions, but the values they represent, okay? And then I'll show you how to flip this to the largest index. All right, so, and then this is it, it's over. If list of min index is greater than list counter, min index equals counter, okay? So in other words, if this statement in line 44 is true, so if that's true, what happens? It goes to the next line, line 45. And then we're taking counter because it's on the right, and we're assigning it to min index on the left. What it means is that, again, pretend that we don't need to know about which min index it is right now. We'll just say the value is 100, like I said earlier. If the next value is 101, so the question is 100 greater than 101? Well, it's not. So therefore, it wouldn't go into line 45. We just return min index. But, well, sorry, we don't return it because we have to go continuing in our loop. We're going to go back up here until this thing here is false. The counter's not less than list size anymore. And then we return whatever the current value of min index is. We're not returning min index after each one of these. Min index is going to be returned. Return means goes to the calling procedure. Calling procedure is right here. Okay, and that's, so here is where we put the position of the first element is, and here's where we're getting the value. Okay, little index where list and array size match up. Okay, that's all we're doing. All right, now watch when we run it. And we'll do some numbers, and we'll just, and I'll kind of try to walk us through them. So I'm just going to type in here a 50, then I'll type in here a 60. I'll type in here a 40. Remember, it's going to automatically compute once I have entered 8 numbers. In other words, it'll then throw the answers on the machine. I won't be entering anything else. I'll put in a 70. I'll put in a 30. I'll put in a 45. Put in a 55. No numbers matter per se. Okay. All right. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So I put in 8 numbers right here. Okay. And then the page says list elements. Okay. List elements. Remember, that's a COOT statement. So COOT statement is nothing. We just typed it in and list elements pop up. Then after here, line 21, print array. Remember, so it goes to the print array. So in the print array, all we're doing is printing via a COOT statement the list of each index value. But again, we're not putting the position, we're putting the elements. So here's the way I entered them. And look down here, they're going to be listed the same way. So 50, 50, 60, 60, 40, 40, 70, 70, 30, 30, 45, 45, 55, 55, and 25, 25. But here, we're doing it on one line because it's in a for loop. So because it's in the loop, okay, we're just going through the loop while it's true. And while it's true, we want to put down the new value. This 50 here is list index 0. The 60 here is list index 1. The 40 here is list index 2. The 70, list index 3. The 30, list index 4. The 50, list index 50. The 45, list index 5. The 55, list index 6. And the 25, list index 7. Okay, so we have 7 values and we input them right here via this COOT statement. Okay, that's all that happened there. So now it says, so the elements are all listed. Now we're looking for the smallest element. So that's when we go back up here. So here they're listed now. And now we're on line 24. The smallest element, again, it's a COOT statement though. So this doesn't do anything right here. It's just typing that in, but it's calling, obviously, then the next function, list little index, where list is an array. Okay, so list little index. And then, so we see here the smallest element in the list is colon. You see, here's where the colon ends, right there, and a space, okay? Right here, and a space. So what you don't see here is the number 25, because that is the value. So look at line 24 from here, where it's the COOT to here. That's just putting the smallest element in the, in list is, or it should have been in, well, whatever, but either way, in list is colon, and then a space. And then here is where we're calling the procedure to get the answer. That's where 25 comes into play. So we go down to the definition, okay? And here's the definition, little index. Remember, the list comes, it was an uninitialized list. We're getting the list from what we're carrying down with us. The list size comes as 8 in this case, okay? And then we're assigning, so we're having a variable called counter and another variable called min index. The counter, of course, is just to loop through our list, right? Just to cycle through the records. And min index is going to be taking the first value in our array, okay? So counter equals 1. Now look at my numbers on the right as I go through these to explain, and you'll see how it comes to 25. So first of all, the 50 over here on the right side, meaning in my little console area, 50, that's assigned to min index equals 0 because it's the first record, so its position is 0. So 50 is that. All right, let me go down here a little bit. So on line 44 where it says if list 0, but 0 is not the number, the value is what we're comparing. So if list 0, which happens to represent number 50, is greater than list counter. Well, here's list counter. We're starting at the number 1, but the number 1 means a number 2, right? Because it's 0 based. So 50 was 0, meaning the first record. So 60 is 1, meaning the second record. So this question is saying is 50. So if 50 is greater than 60. Well, is 50 greater than 60? Of course not. So this is not true. So we do not go to line 45. Instead, we're going to go to the next record. So now counter equals 2, because here, see, remember counter plus plus. That's incrementing. So now we're on counter 2, and min index is still 50. Okay. So this one. So if 50, again, min index 0, it still knows it's 0, and the value is 50. Is 50 greater than 40? Because now 0, 1, 2, we're on the next counter, okay? So yeah, 50 is greater than 40. So now, oh, okay, that's true. That means we go in here. So now counter, which was position 2, you know, the third value in, is assigned, because you assign from right to left. So 40 is now the new min index replacing 50. So now we go back to the top where min index is 40. So now counter equals 3. So 0, 1, 2, 3. So now we're at 70. Okay. If 40, which is the new min index, is greater than 70. Well, is 40 greater than 70? Of course not. So it's not true. So we don't go to 45. We go back up here again. Now the counter is for the next value. So that's 0, 1, 2, 3, position 4 now. So counter equals 4. That's still less than list size. Okay. And we're adding another one for the next iteration. So is, whatever I just said, let's see, it used to be, this is on smaller, so 50, 60, 40, 70. We were 40, and 40 is still smaller than 70, so it was still 40. And now we're at the 30, and 40 is greater than 30. So now the 30 counter for position 4, meaning the 5th record, is assigned as the new min index. So now min index is 30, not 40. So go back to the top. So counter now up to position 5. So 0, 1, 2, 3, 4, and now we're at this one, the 45, which is position 5. So if list min index, which is 30, that's the new min index. Remember, I signed it from the last one because counter was smaller than list min index. So in other words, it was true. Counter was smaller, if that's what I didn't say. So counter 30 replaced the old counter 40. Okay. So now counter up here for min index is 30. Is 30 greater than 45? No, it's not. So we don't go here. We go back to the top. Remember, it was already initialized. So now we're at the next one, which is 55. So that's position 0, 1, 2, 3, 4, 5, 6. Okay. So counter equals 6. Is that counter less than list size? Yes, it is. We have one more to go for less than list size, and that would be 7. So if list min index, which is 30 still, is 30 greater than 55? No, it's not. So it's false again. It goes back to the top as position 7. Position, let's see, 0, 1, 2, 3, 4, 5, 6. Yeah, 7. So it goes back up again. So counter equals 7. Is counter less than list size? Yes, it's the last item we get. Okay, the last item we get. Because remember, we started at 1. So we started at 1 here because we used 0 up here, not in our loop. So that's why we have one less number. So technically it's 1 and then, so 1, 2, 3, 4, 5, 6. That's 6 values, and the other one makes it 7. Okay, that's why we end up getting to there. So now list min index, and index is going to be 25 because it was 30, and 30 is greater than 25. So now we take the 25 as counter and assign it to min index, go back up here again, but now the counter is at 7. It's not less than list size, so it's over. We've gone through every record. So in other words, the 50 was compared to the 60. Okay, the 50 was the smaller, so that was the min index. Then the 50 was compared to the 40. The 50 is not smaller anymore. 40 is smaller, so the 40 replaced the 50. So then we compared the 40 to the 70. 40 is not smaller. 40 is still smaller than 70, so it stayed as 40. Then min index I'm talking about. Then we compared 40 against 30. Well, 30 is smaller than 40, so therefore 30 became the new min index. So now it's comparing 30 against 45. 30 is still smaller than 45, so it retained itself as the min index. Then it compares itself to 55. Yeah, 30 is less than 55, so it's still the min index. Then it compares itself to 25. No, 25 is smaller than 30, so it's the new min index. Okay, that's how it works. Make sense? Yes. Now watch this. Watch this. Relational operator. Maybe I don't want you to take a picture yet because I want you to have everything the way I want you to have it. But just note that right here, when you're looking at things that you want to then change or you might be able to make changes on, just read what the if statement's saying in the case of these kind of loops and arrays. So it says, if the list up min index, meaning again the value, is greater than the list up the counter, then the counter, because that means the counter was smaller, the counter replaces min index. That's all this is saying. So if you want it the other way around, think of it the other way. So put it as a less than. So if the min index is less than the counter, okay, then you want the counter to be assigned to the min index. So all I did is flip that greater than to a less than. Now watch, I got to remember the numbers. I'm going to actually write them down. So I'm going to have 50, 60, I'm going to do the same order, 40, 70, 30, 45, 55, and 25. Now this time though, I want to get the largest, which means the answer should be 70. Okay, And I just changed, oh, I didn't change it. I thought, wait, didn't I just say I changed it? Oh, I did make the change, yeah. So it's less than now as opposed to what it was. All right, so run it again. Okay, now, where do I write my numbers? Right, okay, over here. So 50, 60, 40, 70, 30, 45, 55, 25. Okay, now list elements 50, 60, 40, 70. 50, 60, 40, 70. Same numbers, right? Same order there. Then 30, 45, 55, 25. 30, 45, 55, 25. Same thing. The numbers, so this was just a simple list elements COOT statement, and then a new line, and then we kept on the one line those values based on the way I told you our print array was set up. Here's our print array, which is just this COOT on line 34 with a space. So the first one comes in as 50 because that's zero index. Next one is 60 because that's 1 index. Next one is 40 because that's 2 index. And then 3 and 4 and 5 and 6 and 7. Okay. But now I didn't change the words, right? So it still says the smallest element in list is, but obviously if you look at 50, 60, 40, 70, 30, 45, 55, 25, that's the largest index. Okay. But the smallest element is, in terms of position, is also updated correctly. Because look, 50 is 0, 60 is 1 position-wise, 40 is 2, and 70 is position 3. So the smallest element, which really should say now the largest, is 70. The position of the first occurrence of this is 3. So voila, one simple little change. So what are you going to do tomorrow or the next day or tonight, right? Greater than makes it smallest index. Less than makes it largest index. Of course, what you have to do is then fix everything else on it so that it doesn't just put words that are no good anymore. So just use your head. But now watch this though. I'm going to go from here. Wait, sorry, here. All the way up. All the way up to there. All right, so control copy that. Go back to, where am I? Mind tab. Okay. Oh, not mind tab, sorry. Wait, yeah, mind tab. Okay, mind tab, but I don't want my book now. Get out of the book. 8.2. Okay. Start the assignment. Shoot, I have to remember to let you guys take the picture, or pictures, I should say. Okay. Now mine, remember, if I accidentally leave my code out there, then you guys, when you click on it, start your assignment. For those of you that haven't done it, you'd get a free code. I can't do that. So I'm going to just comment that out and then do my little control V to put it in. So now I'm in and I just run it. That's exactly what I got from my REPL. Okay. Enter 8 numbers. Let's look at my list again. Oh, you know what? Here I want to do it with their numbers. See, here's the numbers. Remember, though, it's 8 numbers and they're looking for 15. So you have to understand it's going to be slightly different. But I'm going to put in, oh, I can't put in all the numbers. You know what? Actually, I can change it. But I don't want to change that because, I mean, I already give you guys so much. I'm just going to do 8, but I'll do it. Actually, I want to get to 0. Dang it. What am I going to do? What am I going to do? What am I going to do? Even though I said enter 8, no, I'm just going to just show it to you anyway, and I'll just do them sequentially from 1 through 8. How about that? So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So list elements 1, 2, 3, 4, 5, 6, 7, 8. And then here they show up as 1, 2, 3, 4, 5, 6, 7, 8 with spaces. The smallest element in the list is 1. Smallest element in the list is 1. The position of the first occurrence of the smallest element is position 0 because that's the first position. Okay. Now, if I want to run it and change the numbers up so it's not the first one, just so you can see it's not being cheated, I'll enter it now the other way. So 8, 7, 6. Actually, let's put 1 now. So 8, 7, 6, 1. So then 5, 4, 3, and 2. Okay. So now it's 8, 7, 6, 1, 5, 4, 3, 2. But the smallest element is still 1. And now it's 0, 1, 2. It should be position 3, and it is. Okay? Now, let's go over here, run our, wait, I'll run checks. Now, again, this is not going to give me a 100, but it's going to give me whatever. Okay, so there's that. I'm not going to submit it, but I can look here and then see this little stuff. Okay, so it contains smallest index. Well, I guess they're saying it does, even though I didn't spell it that way. Smallest index test case. Here's what we want to look at, our test cases. So here's their test case that they want me to run. And I guess they're saying based on what I did. Yeah, because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 15. And here's what I did. Enter 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. In other words, what they're doing is they know that the program, the way I entered it, would then take up the first 8 of their numbers. So they just did it with those numbers. And so I basically got credit for it, in effect, or partial credit for it, because here's the way my list elements would come based on the numbers they wanted me to input. And the position for the first occurrence, let's see what we get on that, is 34. They're saying in that particular case. So if we're looking at these numbers, 56, 34, 67, 54, 56, 87, 66, 92. Yeah, 34 is the smallest. What position is it? It should be number 1. Is 1. So they're giving me credit for it, even though they're not giving me much credit. They gave me 50. And if I click on more details, maybe it would show me more. But either way, the point is that the code will give you a 100 if you just make those little changes. Call it littlest index, call it everything they want you to call it. And don't use the word little index, use smallest index or whatever they said. Make all the changes you need to, but I promise you it's that easy. Now, okay, so I have to delete this though, so that you guys aren't over there trying to get on it right away. Let's see, down to there, delete. Delete, delete, and one more delete, I guess, and now run it again. Okay, now watch. So now I'm going to go to the next one. Well, let me run checks again, I guess. I don't know if it matters. Okay, so now let's get out of this one and go to 8.3. Remember, it's still in my clipboard. Okay, so the very same program. And now I'm just going to flip it to make it work for the largest again. So I'll again comment out this stuff here, so slash asterisk, slash, go down a couple, Control V that. All I got to do is change this greater than on line 55 to a less than, run my program. And now, I don't know if I can pull this up without messing up that. Let me see if I can. I forget the numbers that they said. Well, I think it was just the first 8 numbers is what I said. So I'm going to do 1, 2, 3, 4, 5, 6, 7, and 8. So again, it reads the list elements correctly. But see, now, even though I didn't change the word, it says the smallest element in the list is 8. Remember the last time it said 1, I guess, because it was 1 through 8, right? So 8, and the position is there. So it's perfect. So if I run it over here in my checks, I mean, other than the fact, again, I didn't make a largest index. I didn't do, say, change some of the spellings or whatever. But I promise you, that's a simple 100. All you got to do is do it, excuse me, with the number of elements they want, which is 15. And the words they want. So just look again at your instructions. They want it called last largest index. Okay. And then they want you to have 15 numbers. Make sure you say enter 15 integers rather than mine saying enter 8 numbers. So you just change it to 15 and then change numbers to integers, still leave the colon. And then when you're running it, do it with this information here. It doesn't really matter because any numbers you put in, they're still going to run it pretending that your numbers are these numbers and it'll still work. So you don't even technically need to do that. But either way, test it though, do the run checks and then go. So everything is perfect. Okay, now I'm going to get rid of it out of here. Otherwise, again, I'll forget. Oh, what's going on? What happened? I want to go up. Okay, to there. Delete that. Delete that. On that. And where's my run checks again? To get it back to 0. And that way it'll stay that way for you guys when you're on. Okay, so that's there. Now I'm going to go so that you can take pictures, okay? So all of this stuff here, now I want to make it now though where it's the other way again, the original way, the smallest, okay? So the smallest means down here, I want this, actually I already changed it back. Let me verify, because it's greater than. Greater than is for smallest. So I'll just do them in order. 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, the smallest element is 1 and its position 0. So that's the way it should be now. All right. So, but I don't remember if I haven't done anything in REPL in a while, but let's see if I can just make this good enough for you guys, because it has the line numbers, which is a good thing. So yeah, I'm going to leave it like that. Okay, and let's see. So go ahead and take a picture from line 1 to line 20. Let's wait for that to go. So line 1 to line 20, you got about 15 more seconds. I think I'm doing pretty good in terms of time. I think I said an hour though, and it's probably about an hour and 5 or hour and 10 minutes, but I'm not positive. Hopefully it's no more than that. All right, so you should have that one done, that picture. Okay, so that's down to line 20, find list elements, find list elements. Find list elements. All right, there, get rid of that. Okay, now 21 to 36. Okay. So picture 2 from line 21 to line 36. Take 10 or so more seconds if you want to. That's my water. Okay, that's down to 36. Next, so under an array, Okay, 30, the last one. So 37 down to 47. Okay. All right. So I gave you literally now there 8, 2, and 8, 3. Okay. And it probably would help you on 8, 1, and possibly one other one. Who knows? But for sure, 8, 2, and 8, 3. I mean, I'm talking 100. Okay. All right. So that's that. And let's go ahead and stop my recording now, and I shall say that. Oh, wait. Yeah, I think I gave you enough time on that one. Let me go, just in case I didn't, I forget. Where was I? Here. Sorry, just in case you didn't get that, I think I gave you the normal time, but I forget. So I'll leave it there for a few more seconds in case you did not get picture 3. All right. Remember, all these comments, like basically 43 is 1, 2, 3, 4, 5, 6, 7 lines of comments. 41 is 3 lines of comments. There's only like 8 or 10 lines of code. But I try to write what will hopefully help you remember what's happening. And I tried to walk you through this one where I literally compared, and all these numbers on the side, you could see them. So remember, we checked number 1 against number 2. Then the smaller of 1 or 2 against 3. Then the smaller of 1, 2, or 3 against 4. Then the smaller of 1, 2, 3, 4 against 5. The smaller of 1, 2, 3, 4, 5 against 6. The smaller of 1, 2, 3, 4, 5, 6 against 7. And then the smaller of 1, 2, 3, 4, 5, 6, or 7 against 8. And in the case of what you have to do, it's 15 numbers though, but still no big deal. All right. All right. So now I'm going to go back over here and I'm going to stop my recording. Have a great day.